cover them later in this presentation. And so one thing about array is that in memory, it's assigned with a specific block like this. So it's continuous. And so it's the first step to understanding and solve any algorithm encoding questions. And also, it's very easy to access considering you're only accessing them through indexes. But it's really hard to delete and insert. Well, what I mean by that is that you try to let's say you want to insert an item into an array sequentially, right? So you want to add it to the end of an array, and so what you want to do is you want to copy all the array, and then you add one item to like an n+1 array. So you can resize it. So that's one bad thing about arrays. So the next thing on the list is stacks and queues. So essentially, it's the same thing as array, but it's implemented like this. So as you can see right here, it looks similar to arrays like that, but there are different operations. So with the stack, you can push and you can pop from the top, right? So with the stack, right, you put things on the top, and then when you pop it, you delete it from the top. And with a queue, you put it at the beginning of the queue, and then you keep putting things at the end after that. And then when you dequeue, you remove the first item like that. And how do I erase this? And so a proper definition of stack and queue is that, stack follows the last in and first out, and queue follows first in, first out. That means, if you have a stack, whatever you put in last, you're gonna get that out first. And with a queue, whatever you put in first, you're gonna get it out first. And so it's one of the more basic data structures. It's used to implement more complicated algorithms such as depth first search and breadth first search. And it's harder to specify access specific elements, but it's easy to insert and delete as you only putting it on top. And so next one we have, it's linked list. So this one is, its definition is a sequence of data structures which are connected by links. So think of it like a node, and you have each node have reference to the next node. And so it's the second most used data structure according to tutorial points, and it's one of the more efficient way in a practical application than an array. What I mean by that is that, so an array is allocated in memory with the specific blocks, right? With linked list, you can just put it, every time you want to extend the list, you just allocate this node and then have the previous node point to it. So that's why you're going to see it more in a practical application. Like let's say in BlackBerry, we used linked list to design buffers. And so each buffer would have the reference to the next buffer pointer, and so which make a buffer links. And so each of those nodes will have a value which points to the memory reference of the data in the memory. And so it's similar to stacks and queue. It's very easy to insert and delete, but it's hard to access. And so next is, we have several types of linked lists, which the most common type is the singly linked list. Like you will see a lot of problems with these. And so as you can see from this figure right here, so each node has a reference to the next node right here. And so until it hits the end, which is null right here. Oh, clear, delete, there you go. And next thing is doubly linked list, which is similar to the singly linked list one, except this one we have a next and we have a previous, and there's still value in the middle. And then we have a circular linked list, which this is very easy to understand. It's like a singly linked list, except at the end, the last element, the last node has reference to the first node, which makes it circular. And next is hash map. And I think Ari can talk about a little bit about it.
Yeah, so hash maps are great. I like the little quote here: when in doubt, slap a hash map on that problem. We'll actually see this come into play a little bit later. But yeah, so maybe if you can go to the next slide quickly. And sorry, I'm not gonna be able to draw like Lamb here because he's presenting now, but that's okay. So yeah, with great power comes great responsibility. This is just maps are great. Okay, so if you go to the next slide.
Yeah, by the way, I give you access control. So if you want to click it, yeah.
Oh, I can click stuff. Okay, cool.
Yeah, you can click stuff.
That's awesome. Okay, cool. So there's a lot of words here. First off, I'm going to start off with something. Hash map is very similar to the concept of an actual human dictionary, because what it is it's a pair of key value pairs. So let's say you're looking up the definition of the word hello. You're going to see like the definition of that would be a greeting that like to say hello to someone, whatever, right? It's key value pairs. The secret and the reason they're so powerful is because they sacrifice the ordering of arrays. So what do I mean by that? To start off, arrays have an index. So if you say index 2, there's going to be something there. If you say index 5, there's going to be something there. Hash maps don't have that. They don't have indices. What they use instead is kind of a custom key as the index. So that key could be a string. It could be an integer. It could be anything. It could be any object. So it's pretty powerful. Before I keep rambling on, I'm kind of just going to read what's on the screen right now. So the definition of a hash map is a data structure made of searchable set of key value pairs. The keys are unique and the values are unconstrained. That is one thing I didn't mention. The keys are unique. That means that no two of the keys can be the same. And then, yeah, think of it like a dictionary pairing word to meanings, but instead items are stored in an array. Below, down here, you can kind of see where it says keys and hash function and buckets. This is kind of like the behind the scenes of how it works. This isn't too important for the actual leak coding part, as long as you know how to use it. I'm seeing in the chat, someone's asking, isn't this a hash table? Hash table, hash map, dictionary, they all mean the same thing. One of my biggest aha moments when I started leak coding was that the dictionary in Python is the same thing as the hash map in Java. When I realized that, my life was changed forever. So those are very important. This is a very important data structure to have. So the importance of this as well, again, why it's useful is the access time. So basically this little area down here where it says done via hash function and gives the hash code and the compression, basically summed up what this is saying is that, so to add something to a map is constant time. To remove something from a map is constant time, and to look up something in a dictionary / map is constant time. So this is like super OP, as they say, when you're doing leak code problems, because this can drive your time complexity way down. Whereas, like, for example, so let's say you want to search for something in a dictionary, constant time. If you want to search for it in an array, you have to look at every single element in the worst case, so it'd be linear time. So yeah, I think we can go to the next slide now. Oh, actually, you said I have access, so I can just click.
Yeah, you should have access.
Yeah, okay. So now we're going to talk a little bit about graphs and trees. And this is where it gets a little confusing. As Dim mentioned earlier with the stack and the queue and the DFS and BFS functions, those will kind of come in handy here. They kind of go hand in hand. There's a quote here: if you're going for a tech interview, there's probably a 50% chance graphs are on it. It might not be graphs directly. It could be just the DFS or BFS problem, but there is a good chance that something like that will be on it. So let's see here. So I'm just going to first read the definition. So a graph, call it G, is a pair of sets, V and E, where V is a set of nodes, which are vertices, and E is a set of edges, pairs of vertices. I understand this barely myself because it's very cryptic and mathematical and thing. It makes sense, but basically what it's trying to say is there's little nodes all over the place, little circles, and they're all connected with lines. A vertex is one of the nodes, and an edge is the line that connects them. In your earlier days, at least, you're not going to see too many graph problems, and it's more going to be tree problems. And it's actually going to be a subset of trees called binary trees. Now, what a binary tree is, it's a little bit easier to understand. It is a node that has a left child and a right child. So as you can see in the third picture here, where there's like 1, 2, 3, 4, 5, 6, 7, this is a binary tree, and this is the most common form of tree you'll see in your interview problems. Yeah. Okay, so I'm going to go to the next slide. So, and then here we have heaps and priority queues. Something special here: heaps and priority queues are actually the exact same thing. They're just different names, and they're language based. So Java likes the word priority queue. Most other languages that I've seen use heap, but since we teach primarily in Java at York, you're going to hear the word priority queue a lot, but just know that they're, again, interchangeable. Okay, so let's see here. So I'll read the definition again. So heap / priority queue is a tree-based data structure that acts like a stack or queue, but with an additional priority associated with each element. as its node. It is a binary tree, and each node is a KV pair. So now a little confused. So first of all, also it comes in 2 flavors, min heap and max heap. I'll explain the difference in 1 second. So essentially what a heap is, to my understanding at least, is a tree where it's like semi-sorted underneath, but we always know what the top node is going to be. In the implementation of a max heap, the top node will always be the biggest element in the heap. And then in the implementation of a min heap, it'll be the smallest element in the heap. And essentially, this is a little bit better than a list, because what you can do is, let's say you need to continuously get the smallest number in something. Insertion into a heap is log n time, and removal is log n time. Actually, I'm talking a lot about these times. I'm now realizing there's a slide after this about the time complexity. So if you are confused, you will understand what I'm saying later with the log n time. But basically, all you need to know that it's faster to get the minimum from a heap than it is to get it from an array. And that can be useful in a lot of different places. Heaps, I'll just read off the slides again, satisfy the following 3 properties. So the heap property says no child node has a higher when it's a max or lower priority than its parent node. A complete binary tree. So every level of the tree, except possibly the last, is filled with nodes. So it's basically a balanced tree, which we can talk a little bit more later. And the last node is the rightmost node at the bottom level. Actually, I'm not sure about that. I don't understand. Well, so Dan, can you explain that one?
Yeah.
The third line? Yeah.
Yeah. So as you can see right here, well, again, these slides are made hush here,
Oh,
but
yeah.
I would assume that he means this node right here. So this is
Oh,
the
yeah.
last
Okay, that
node
makes sense.
within
Sorry. Yeah. Yeah. Okay. And then there's a bonus. The root top node is always the first node, highest or lowest priority depending on max or min. And so there's actually 2 implementations of heap. The Java actually uses an array-based implementation. Oh, sorry, a node-based implementation where it actually has nodes with the left and the right. But most other languages use an array to store their heaps. So yeah, I think that's the heaps. And then, it's not letting me go to the next slide. It's, I think it's on the pencil. Yeah, sorry.
I got it.
Sorry about that.
All right. So
Okay.
how are we following so far? Like I know we just dropped a lot of information on you guys. Do you guys have any questions? Let me read the chat real quick.
Good point. Yeah.
Watching anime with subs. Ooh.
Yeah.
Moving a bit too fast. Yeah. All right. We'll try to slow it down. But do you?
Sorry about that.
Yes.
Yeah, it's kind of a lot to take in, like as a first year, or even if you're like in second year or something like that.
Yeah.
So I think we should like ask some questions in general if you guys have any.
I think we should be able to post the slides.
Yeah, we should be able to post the slides.
Yeah.
So I think one of the reasons why they try to separate priority queues from heaps is because like some might choose like a different implementation, right, for a priority queue. Like you might pick like a really inefficient way of just like maybe you have an array that's like unsorted and you just always take like you always do like a linear search to remove the maximum element out of it or something like that, right? So like they're trying to leave the internal implementation of the priority queue as abstract and just present you with the tools that you're looking for.
Well, I mean, that is language agnostic as well. I think every language you use, like for example, Python, they call it a heap and you have to store the array yourself, but you still do like heap pop, heap push, heap whatever. And it's all done like behind the scenes. You don't actually have to understand how anything works as long as you understand what it does and how fast it can do it. I think that's the key takeaway, at least for this. When you take 2011, it's going to be a little different. They're going to teach you how everything works. But the point they're trying to get across is it's always important to know how something works so that you're able to actually do that thing, right? It's like if you can understand how the code works, but it's always better to understand the lower level as well.
Yeah. Okay,
if
so
anyone
I
has
think
any specific questions, you can shoot as well. Yeah.
Yeah, I think Abdullah, Mohammed Ibrahim, do you want us to go over the hash map again, or the graphs or the trees?
I think we should. Yeah. Oh no.
Okay.
No, it's fine.
Okay. I can try and go slower. I have a tendency to talk really fast. I'm doing it.
Yeah,
right
we
now.
can go over.
We can go over it again. Mhm.
Hash map.
Should we do like a TLDR this time though, and maybe not go into as much detail? Like just give like a TLDR of what it actually is. What do people think? Okay. Dennis is saying a general idea of what each structure is. So essentially what the hash map is that, so first let's understand the array. The array, given an index, you can find a value. The only difference between the array and the hash map is that for a hash map, given some arbitrary key, you can find its associated value. So it's not linear in memory the way an array is. It is anything can be the key, and then anything else can be the value. Obviously, there's type constraints there, but that's like the highest level way of explaining it, really. And you can really think of it like a dictionary, like the book. You can, the key is the name of something. So again, like the example of the word hello, and the value is the actual definition of the word hello, and they're associated with each other.
Yeah, so think of it like a dictionary. You have really fast lookup time if you have the key. That's it.
Yeah. What's
Uh,
the bucket?
So a bucket could be all sorts of things. It could be an array list, or it could be a tree or something like that. It's just a way.
I don't think it's too important to know that right now, actually, because you'll learn that in 2011, and you don't actually need that for the interview, which is why I was kind of like, when I saw these slides, I was like, maybe I should have changed them a little bit, but I didn't have too much time. You don't have to worry too much about the underlying, as long as right now you understand what's going on. And then, yeah, once you take 2011, they'll teach you all this lower level stuff.
We're just trying to, give you guys an idea of what type of stuff you're gonna like face when you lead code, because this is like, it's not in like any specific programming languages. It's like a universal, like in every language, I think there's stuff like this, right?
Yeah.
All right, let's move on. So graphs and trees.
Yeah. So again, we'll do a high level. Basically, I'm just gonna stick to binary trees right now, because as when you're starting off, you really shouldn't deal with the harder graph problems, or even tree problems are a little harder to understand. So, excuse me. Yeah, exactly what Lamb just circled there. So essentially what it is, it's a node, where you can think of a node as a class or anything you want. Basically, it's a piece of memory that has a value, and that can be an integer, a string, or whatever you want it to be. And then it has a left node and a right node. And essentially, this is just a very common way of presenting data, and actually a great way to showcase this is to look at a more complicated tree on the right. Your computer is actually, everything saved on your computer is actually in a tree. So you'll have your, like usually on Windows at least, it'll be your C drive, and then you'll have all your folders there. So you'll have your user directory, you'll have your program files, your documents, everything. Every time there's a folder inside of a folder, that is just another node of the tree. Someone in chat is saying trees are like pathways. If statement or loops, but it's more complex.
Well, sort of. It's what we call a control flow graph. So let's say you have an if statement, like you start with a block over here, and then if yes, then go left. If right, if else, then go right, and things like that. I think that's what you're talking about, right? So that's what we call a control flow graph. All right, I think so. This would be.
So just a quick as well, graphs and trees will be a very big part of 2011. We're giving you a like 10-minute recap of like a 4-month course. So obviously it's going to be a little hard to like understand everything on the first try. I think as long as you understand up to before graphs and trees, you're at least set to start on a pretty good trajectory. Even without maps, you can get pretty far. But I think maps are like the last thing that you really should know before you can start. Graphs and trees come a little later. If you don't know them, you might not need them for the easier jobs, like when you're just starting off. So I think it's okay to not know this right away.
Yeah.
Especially if you haven't taken 2011 yet.
Yes, and to address Modib's question, so all trees are graphs, but not all graphs are trees, if you think about it like that.
Mm-hmm. Yeah.
So heaps and priority queue. So essentially, I can take over this one. So essentially, A heap is just a binary tree, so a balanced binary tree, except it must satisfy some condition. Essentially, a max heap, then the largest element will be on top, and a mean heap, the largest element will be on top. Basically, that's that.
And
That's all.
the key to this is that this allows you to find the max or the min value of a set of data a lot faster than if you were using any other data structure, really. So if you're using an array, you would have to look at every single element in the array to find the max. But if you're looking here and you just want to find the max, you just know where it is. You don't have to look at everything. You just have to look at the first one.
Yep.
And that's basically like the whole point of the priority queue existing.
All right. So let's move on. So how do you actually measure performance, right? So you guys probably heard about the big O notation. And so essentially the thing with that is that it's a way to measure performance with the scale that scales with the size of the problem. So what it means is that, if you have an array of n size, right? So how many instructions do you need to solve the problem, and how much space do you need to solve the problem? So that's what they mean by time complexity and space complexity. So what time complexity means is that how many instructions do you need to run to solve the issue. Let's say you have an array of size n, so if you need to access every single array elements, so you need to access every single. So you need to run n lines of code, right? So that's why we call, if you have one for loop and it accesses all the elements in an array, that means it's on time. And if you have a separate array to store anything that you want, you have an extra hash map to store extra stuff. That means you need to store n variables into memory. So that's why it's on space complexity. And so these are kind of things that will come in handy when you need to trade off, time complexity with space complexity and try to make the best performing program that you can. And yes, can trees have no roots? No, a tree must have a root.
I think what he's referencing to is we had actually pictures of trees and graphs. Graphs do not need to have a root, but trees need to be rooted.
Yes, so that's one key difference between a graph and a tree.
Yeah.
All right, so let's move on. So, if you look right here, right, so you have two for loops. Nope, that's the wrong thing. So you have one for loop here. So this one will run, let's say, n times, and this one will run n times. And so in total, you have to run n squared times of instructions. That's why we call it an on square. That's pretty much just that. And go on next slides, and I'll share you guys a secret. Like, a lot of these things may be hard to remember, but then again, do remember that when you solve these questions, you have a cheat sheets online and things like that. So I'll share you the cheat sheet. So it's right here. So you guys should really bookmark this link right here. So it's bigocheatsheet.com, and it will show you the complexity of different things. So as you can see right here, different data structures have different access, search, insertion times. And so you can use these for reference when you studying for your 2011 exam, or when you're studying for your 30-101 exam, or when you solve LeetCode questions. And that's pretty much that. Does anybody have a question before we move on to the next topic? Yep, big O cheat sheet. You guys should really bookmark this link, because you guys are gonna be referencing it a lot.
Yeah, and you once you do it for enough time, it kind of just sticks in your mind.
Yeah.
That's why, like, when I was explaining everything, I was kind of just blurting it out, because
Yep.
in my head, that's the first thing I think of when I think of all these data structures. I think of their time complexity and like the trade-offs of everything there.
So as you can see right here, like Ari said, a hash table has 01 O1 access time or whatever.
Yeah.
ON search.
Well, all we really care about is the average case, because there is average and worst case.
Let's see
Usually when we talk about average case. So that's why I was saying constant time there. Yeah.
How do we read this website? Okay, so if you look at this big O complexity chart right here, so you can see an algorithm of O log n and O1 is really good, right? Because it's excellent. It scales really well with the number of elements, and you see how as the number of elements increases, the number of operations that really increase because it stays right here. For ON, the number of elements increases, but the number of operations still like down here. ON log n was starting to go up a little bit, and then ON square with number of elements increases, and then you have to. This is how much the number of operations increase. And so this is year 2 or 3 level stuff, but it's good to learn early because it's not a hard concept to understand, because it's just simply how your code will scale up with the number of the size of your problem.
Well, actually, you'll learn most of this in I think Math 1019, if I'm not correct, which is the discrete mathematics course. Yeah. Dennis is confirming that for me. And it's really easy if you want to just figure out which time. You have 2 time complexities and you want to figure out which one's better in the form of n. Just plug in like an arbitrary number like 10 into n, and you'll see one of them is going to be bigger than the other. And basically, whichever number is smaller is the better number. So like intuitively in your head, a number squared is going to be bigger than just that number itself.
Yep.
The log of a number is going to be smaller than the number itself. Like, and it's pretty simple to think of it that way. Yeah.
Yep. We preferably do not want ON.
Sometimes it's necessary for like some really complex problems, but ideally, in an ideal world, everything is O of 1 time, which is constant time, which means the code actually does not rely on the size of your array at all. So if your array, I'm just saying array for simplicity here, but let's say you have infinity amount of things in your array or whatever, O of 1 time will always be the same, no matter how big or small it gets. And that's ideal. It's almost impossible to use that in most cases, because like, let's say you have a list of things and you want to find it. You have to look at everything to see what the biggest one is, right? So yeah. Essentially, you always want to minimize as much as possible, but sometimes it's necessary to go up.
Yeah. So, you can look into here, like this is the time and complexity of each sorting algorithm. Eventually you touch this kind of stuff in your later years, but essentially you can you can refer back to this website, and it would tell you which sorting algorithm is better. And so, yeah, let's go to the
people DMing me, what language is this? And I'm it's like, again, it's not a programming language. It's just like
this is a way to analyze a piece of code to see how fast it runs, and it is language agnostic. The language does not matter here. A for loop in Python, Java, or Swift, or C, or whatever language you're using, a for loop over an array of n items is going to be n time complexity. That's just how it's going to be, and there's no way really around that. It's a level above actual code, and it's more of the idea of how fast is it running, and it's more of an analysis tool than anything else.
Yeah, so Grace, preferably you want to choose the kind of data structure based on the big O, but then again, you have to keep in mind that if you have to keep in mind of the space complexity and time complexity trade-off, as in if you want to store items for faster caching, faster access, you have to store them, right? So you have to put them in memory, and therefore you have to need more space in memory, and you need more resources, and that's why it's called space complexity. We good here? All right.
I think that's enough basis to start with the actual questions.
All right, we're going to go back to the actual fun stuff. All right.
Cool.
So how do we actually solve a LeetCode problem? Now, we just dumped on you like a butt tons of knowledge, but how do we actually solve an actual LeetCode problem? And so these slides are going to be based heavily on cracking the coding interview.
Bible.
Yes, the Bible, like Ari's saying. So it's $44 on Amazon. And if you're, if you're a real tryhard and you really want one, you can always order it off Amazon. I think it's worth it. But also, again, like I'm not condoning piracy, but there may or may not be a PDF version floating all around online. Just saying. I do not condone
Yeah, don't
piracy,
be a
but
cheapskate, guys. Books also help you learn coding. Just please read books too, guys. I know
yeah.
we don't read any books anymore, but just read books.
Which one is more important, speed or space? That's for you to decide. So
So that's
preferably you
actually
want speed.
yeah.
Ari,
I was gonna say
go
that
ahead.
that's a common trade-off when interviews. Oftentimes you can actually change, you can sacrifice speed for time and vice versa. They're kind of inversely proportional. As your speed gets better, your space usually inevitably gets worse. So there's kind of a trade-off, and you have to find, basically, depending on what the problem is, what is better. It's very much subjective actually in that case. And so yeah.
All right, so here are the basic steps on how to solve an actual programming question. And so the first one is you have to read the question very carefully. Most likely or not, you're going to need all the information that you're presented in the question. So essentially, is the array sorted, or is it unsorted? What kind of time or complexity are we allowed, and things like that. So you have to read the question very carefully. Next, you want to create your own example. So you don't want to code yet. You want to create your own example. Like you want to start drawing. Like let's say you're thinking of a tree. So feel free to just start drawing on like a piece of paper, a whiteboard, or anything you have, paint. So this is why it's called whiteboarding, because you can just draw stuff on your thing and let the recruiter knows what you're thinking. And so after this, you want to brute force through it. Like don't code just yet. You want to come up with the fastest, something on top of your head. Like, what do you think? You can just got to brute force through it, and then you worry about optimization later. Which bring me to the next point. You got to optimize it after that. So BUT is an acronym, stands for bottleneck, unnecessary work, and duplications. So I'll go over that later. So after that, you walk through your solution in your head. You want to make sure that do not code just yet. You want to think that, okay, does this solution make sense? Where am I stuck at? Things like that. After that, you will actually start your implementation. And so at this point, preferably you would have something that is already optimized. Although if it's not optimized, maybe if you can try to implement it and then look at your code on a piece of paper and see how I can actually optimize it. And after that, you want to test your code. And so we'll go deeper into these steps with a very common programming question. This is FizzBuzz. And so I'm sure you guys, I don't know if you guys heard of this before. I've seen this problem asked by RBC, at least RBC. I think I've seen it with IBM as well. And so they will give you like HackerRank challenges, and they will ask you to solve FizzBuzz. And so believe it or not, like I've heard from people that this programming question alone will take out probably 50% of the candidates. Yes, we'll go deeper into step 3 and 4 with this example right here. And so this is essentially FizzBuzz, right? So you given an integer n, you return a string array of answer. So if the index I is divisible by 3 and 5, you print out FizzBuzz, divisible by 3, fizz, divisible by 5, buzz, and then so on, so on. There are many variations on this, but this is the gist of the problem. And so you want to read the question carefully. And so, what information are you given? Right, you're given an integer n, right? And you want to return a string array answer, right? And so, you look at all these parameters and all these inputs, and you're trying to figure out, okay, so what do I need? Yes, the dislike ratio is very surprising because this question is really easy, but believe it or not, it takes out roughly 50% of the candidates when applying to a job. Should you keep yourself to a soft time limit? Preferably, you would want to keep yourself to a soft time limit, because when you're given an actual problem, that they're gonna time you, and they're gonna cut you off after a certain amount of time.
The average time of cutoff is 25 minutes. I think when you're first starting off, take 2, 3, 4, 5 hours if you need to get through it. Like the first few questions, it's always really hard to start. I'm not gonna lie. It's like the first few ones are always complicated. Very, very quickly after that, though, you will start to get really good at it. Or when I say really good, you'll start to understand things a lot faster. And then maybe then give yourself a 45-minute time cap, and then slowly work your way down to 25 minutes. But 25 minutes is usually the standard for interviews.
So now you want to create your own examples, right? So let's say you want to, give a very generic example. You don't want special cases, although you want to cover that later. You don't want things like, corner cases. And so a good example for this problem would be 5, 2, and then 0. 0 is a very special case, because you're going to give back nothing, 0, right? So you want to create your own example either on a piece of paper, or you want to create your own example on whiteboard, anything you can draw, right? And so you want to brute force through it. So Admira seems to have a right idea of the issue, of the question. So you want, for this step, you want to use all the resources you have. So you want to throw in all the for loops. You want to throw in all the data structures. It doesn't matter if it takes like 5 billion years to run it. Just as long as you get an actual working example, you're good, because you would be surprised the amount of candidates that don't actually that are not able to come up with a brute force approach, right? So it doesn't matter if you throw for loops at it. It doesn't matter if you throw data structures at it. Just use all the resources you have. After that, now is when you optimize it. And so about BUD. So BUD, so it's BOD. B stands for bottlenecks. So U means unnecessary work, and D means duplicated work. So what bottlenecks mean is that, if you have one faster part of the code, and you have one slower running part of the code, if you don't get the slower running part faster, your worst time complexity is going to be the slower part of the code, right? Unnecessary work is another trick to optimize your code, as in, as programmer, we're very lazy. We don't want to do anything twice. We don't want to do anything, redundant or anything like that. So you want unnecessary work in your code. And same goes with duplicated work. So you don't want to duplicate code and things like that, right? Yes, so that's where functions would come in handy. But then again, yes. And so this is why you should refer to the book for more tips on how to optimize. This is like the general, very basic tricks to optimize your code. So now you have to think about, so I'm seeing some solutions in the chat. And so this is where you walk through the issue, right? So you run a for loop. So because you want an n size array, right? So you want to from I in range n. So this is Python, by the way. So in the form of Python. So if it's mod by 5 and 3, then you print out fizzbuzz. Mod by 5, you print out fizz. Mod by 3, you print out buzz. Things like that. Very simple. And so now is the important part. We get to the implementation, and I have one thing to beg of you, that is, please write good and clean code. Like, please, like, what I mean by that is no ABC for your variables, no single letters and anything like that. You want to name your variables and functions something actually makes sense. Like, I don't know, like something that actually makes sense. Do not name it ABC123.
Yeah, because like I used to name my variables like weird ass names, and what if I do that in a coding interview? And then somebody who's interviewing me would look at my code and be like, what the fuck is these nuts? Like, why did you put these
Yes.
nuts as a name? Like, we shouldn't do that. And if you do that in a coding interview, well, you're screwed.
Yeah, Grace, do not do. It's good programming practice that you want to name your variables and functions something actually makes sense. So it's something called clean code habit, and so well, you cannot come up with a good name. So I don't know. Let's say you have an array, so you would be string. So you have R str. So R means array, str means string, and things like that, right? So try to come up with something that makes sense. So another thing is you have to watch your indentations and brackets. You'll be surprised by how much indentations and brackets help you when you program. Like they're really helpful for when trying to find bugs, trying to find where your issues are and follow the scope of your program and things like that. So if you have a repetitive work like a Modip said, you have to you preferably would want to make a function for it, because you don't want to do something multiple times. It's repetitive. And so I'll be watching you. Like if you do any of these things, I will personally reach out the monitor and just stare you down. Okay. Do not do anything like this, because it's good. It's called good clean code habit. And so you want to do this all the times. You'll be amazed how much these tips help you, either coding interview or doing your homework, basically when you code in general, right? But again, you should know when to stop as well, right? Like you don't what was the last thing written? If it's a repetitive work, then you should make a function for it, right? Yeah, so after this we'll cover some of the problems, right? So you should know when to stop optimizing as well. You don't want to try to be too smart, and you don't want to end up on R bad code. And this is a good example. Is numbers equal? Why you do this? Why don't you just use the equals sign? And believe it or not, this is actually in somebody's production code. And so this is my solution for FizzBuzz, as you can see right here. Let me draw this. So run from int of I to n and return a list of string, right? So if you look at the parameters of the function, you can see right here that it requires to return a list of string. So I put everything into answer, and if I mod 3 is 0 and I mod 5 is also 0, you add FizzBuzz to the answer. If I mod 3, you add fizz. If I mod 5, you add buzz. And then otherwise, you want to add the value of the value of I. Can I explain for loop? Yes, I can. So essentially, for this problem, right? So we want to have a for loop that you want to go from 1 to n, because you want to have an array of size n, return array of size n, where if the index mod by 3 and 5 equals 0, you want to have FizzBuzz in the array. And if you have I mod 3, you want to have fizz. If I mod 5, you want to have buzz. Otherwise, you have that. And as for the complexity of this array, of this program, it's O(n), because as you can see right here, it would run n functions, n instructions. So it would run this chunk n times. It doesn't scale up, even more, even if you throw in more, bigger numbers, it would just run these operations n times. So I'll show you the result, right? So essentially, LeetCode FizzBuzz. LeetCode. Give it some time for it to load. Unless my browser actually crashed. All right, yeah, here we go. All right, so if you run this code, right? And so you can see right here, if I input 3, you can get 1, 2, and fizz. Because so 1 means answer I is, if none of the above is true, then just put I in there. If 2 is also put I. If 3, however, you want to put fizz. Oh, it's just because of the it's just the parameter of the questions, right? So you want array size n. So you can technically you can run from 0 to n as well, right? But and then let's go back. We only have a few more slides before I'll let Ari finishes off. So you don't want it to be too smart, right? So look at this example, right? So this one is a really bad example. Why? Because he's trying to be really smart. So he has a string, and then if I mod 3, you add fizz to the string. If I mod 5, you add buzz to the string. And then if it's empty, that means we didn't do any of this work. We didn't do any of this work, then simply just add the number to the string, right? And so, why don't you guys just, he can do that, but why? You can just do what I did, which is much more easy to understand and things like that. Oh, this one is not faster. So this one I pulled from here. So another thing with LeetCode is that you can see your submission right here. So my submission runtime is 1 milliseconds. And that one, I think it's over here. Yes. So it's something like this. So you don't want to be too smart because sometimes it would actually hurt your case, right? So, or you can do something really smart. This guy is clearly just trying to be super fancy and everything. And so, he make it really fancy. You can put extra stuff in here, bit mod 7 and mod 9, things like that. But, for this simple question, simply do a for loop and loop through the whole thing and you should be fine. And so, after that, you want to test it with your custom numbers and test cases and things like that. A few final notes is that, yeah, so if it's, make it easy to understand. Keep it, like Dennis saying, keep it simple, silly, or, just, keep it simple, stupid, right? So if it's an interview, you want to keep talking. The more you talk, the better, because your interviewer wants to hear how you solve the problem. And so in the end, coding challenges are meant to show how you think, and it is okay if you can't solve it. Like, as long as you keep talking, you show them how you think, you will actually, you might be able to get the job. And why is FizzBuzz a hard question? That's a good question, because a lot of people actually fail the thing. Like, according to some sources, 50% of the candidates get rooted out. Because some people, they don't know coding at all, and then they try to apply for some coding jobs and they get, this simple question, and then they just choke on it. And yeah, and then with that, I think I'll leave it to Ari to take care of some of the programming questions.
Yep. First off, I saw someone in the chat put, do you give advice on resume formats to get a co-op? That is an amazing question. Not in the scope of this event, but there is I believe in the CSHub Discord server, a resume roast place where you can, like, obviously anonymize your resume and then send it there. And then essentially people who have had internships and success with their resumes can review your resume and tell you what's wrong with it, what needs to be changed. And yeah, so that's a great resource. I'm going to share my screen. You're going to have to give me one second here. Let's see, share. So we're going to do it now. so can you guys see the code and then not see all my Zoom stuff on top? Just want to confirm that.
Yep.
Yep.
We just see
Cool.
ourselves.
Okay.
You could maybe
Beautiful.
zoom in a
Okay.
bit.
Yeah. I'll make
The
this
browser
bigger.
control scroll or whatever.
Yeah.
Yeah, that's good.
Okay, cool. First off, I'm gonna ask. So I am much more comfortable with Python, but does anyone want me to do it in Java? If enough people want Java, I will do it in Java. Let's start with that.
Should I make a poll?
Yeah, if you can do a poll, that'd be great.
How do I do polls on Zoom again?
You have to go to the website.
Or just put like a coffee emoji for Java and a snake emoji for Python, and then we'll see which one has more in the chat.
Yeah, perfect. Oh, can people even put emojis in? Oh, there.
I think so. Yeah, I'm seeing a lot of Pythons. Awesome.
Snakes.
That's what I like
A
to
lot of
see.
snakes.
Okay.
Eh? Perfect.
By the
Okay,
way,
and then
just-
if you, I can, yeah.
Python it
Sorry.
is. Oh, we have one anonymous. We have one anomaly. It's JavaScript.
Not gonna lie, I actually solve my questions in JavaScript and TypeScript. I'm not joking. Like I actually do it because I don't know. I enjoy it. That's what I do.
Fair. That's fair.
When
Everyone
it
has
all
their own
comes to
language.
personal preference at the end of
Yeah.
the day.
It's
Yeah,
very
that's true.
based on personal preference.
Okay, so what I'm going to do first, we're going to read the question. We're going to identify the question. Then we're going to do exactly what Lam told us. We're going to go brute force first. We're going to realize that our brute force is actually not going to pass the test because it's too slow. And then we're going to realize where our problems are and we're going to fix them. It's all going to happen now. So first off, does someone want to read the question? Anyone? Or do you want me to read it? If someone wants to read the question, just unmute and go for it. I'll give you like 5 seconds.
I'm gonna do it.
Okay, go Dennis.
Okay. To sum, given an array of, oh my gosh, Ari, can you zoom in, please? Because I can't read the.
Sorry, yeah.
Thank you, Ari. Given an array of integers, nums, and an integer target, return the indices of the two numbers such that they add up to target. You may assume that each input would have exactly one solution. You may not use the same element twice. You can return the answer in any order. You want me to read the example too? Is that enough?
No. So
Ari's turn.
does anyone not understand the question as of yet? If so, we can go through the examples. Actually, I think it's good to go through the examples, but I'll go through them, Dennis. Thank you for reading that. So essentially, we have a list called nums with 4 numbers in it: a 2, a 7, 11, and a 15, and a target, which is 9. And now, assuming that there is always 2 numbers, sorry, hold on. So let's start first. Okay. We have to find 2 numbers in the nums list that add up to our target. And we can make the assumption that there is only ever going to be one solution in this list. So in this case, I mean, looking at it, it's pretty obvious that 2 and 7 add up to 9. So what I actually need to do is return the index of 0 and 1, because 2 is at index 0 and the 7 is at index 1.
I have a question.
If you want one more example, yeah.
So what I'm understanding from it is for example, let's say our array has 1, 2, and 3, and we give our target 3. So we're looking for whatever numbers we have in that list that adds up to 3, our target.
Correct. Yes.
All right.
And to make it a little simpler, it's always going to be 2 numbers that add up, and the number, you can't reuse a number. So like, for example, if our target is 4 and we have a 2 in our list, we can't do 2 plus 2 because you can't use the same number twice. So I think with that, we're set to start. Does anyone want to tackle the question? Does anyone have an idea of how to do this? Because if there is, we can actually go off of that.
Yeah, I would like trying the brute force solution.
Okay, cool. So what do you recommend I do?
I think you should go through every single array element. So
Okay.
you should first pick an array element. Like, so you get an array element, and then you have another loop that goes through all the other array elements to check
Gotcha.
if you can find something.
Okay, cool. So let's do that. So perfect. So here's the secret, is that we actually need the index and the value. So what I'm gonna do, just to keep it simple, there are some more Pythonic ways of doing this, but just in the interest of, since this is like a beginner intro workshop, I'm gonna go simple. I'm gonna say for I in range length of nums. And basically what this does, this is the equivalent, oh, sorry, my typing is exploding on me. Basically what's happening here is we are basically doing the for loop that you guys all know in Java, which is like the length of the list. So basically I is going to increment however many times there are elements in nums. Cool. So Alec, you told me to start with this. Now what do you think I should do next?
For every element, you should have another for loop. Well, you should
Okay,
first
cool.
store
So
the value. Yeah. the index you
Yeah.
have. And then you're gonna do add I plus j to see if it equals target.
Okay, so we're gonna do nums at I plus nums at j, right? And you're saying
Yeah,
if this equals, oops, sorry, double equals what?
the target.
Target, what should I return?
You should return index I, index j.
So I comma j, cool. So if I run this, this should just work, right? This is a pretty standard solution. Can someone tell me what the time complexity here is?
O of 1? No,
This
O
is
of
not O of 1.
2.
I'm seeing the answer, the correct answer in the chat. It is n squared
Oh.
time. Does someone want to unmute and tell me why it's n squared? So people are saying because of 2 for loops. Now let me ask. So this is not the code. This is not the correct solution. But if I were to move this for loop outside of here, right? What is this time complexity? So hold on. Let's say I want to print everything first, and then I do this, right? Is this still n squared? This is not a correct solution, but I'm just asking, is this n squared? Cool. A lot of people are saying n. That's really good. So people realize, so the reason that it's n squared is not because, the reason it's not n squared, the reason it is n squared is not because there's 2 for loops. It's that there is a for loop inside of another for loop, and each for loop is going over n things. So essentially what we're saying is here, we're going to go over n elements. And for every one of those elements, we're going to go over another n elements, which leads to n times n. Cool. Now, does anyone know of a way we could actually make this a little bit faster? Or if there are any questions before we try and make it faster. Someone wants to unmute and ask a question. I'll take that as a no. Oh, yeah.
Wait, it's okay. I'll interrupt. And so isn't this technically wrong because you're still comparing both for loops start at the same index, right? And so you'd be adding the same index to the same value at the same index
very
twice.
Good. Very good. So how could we fix that?
My answer.
You can change it so that j cannot equal I. You can just put it.
Okay, so how would I do that? So
for
another if
j
statement?
array, you can just put that in the clause. So it's just if nums plus j equals target and j does not equal I.
Okay. So if this, and so actually what we should do is actually do it in the beginning. So I does not
Right, that
equal
makes more
j,
sense.
and yeah. And the reason it matters, I don't know if everyone's here has learned, but there's this thing called short circuiting, where basically if the left parameter is false and it's an and statement, it's not even going to look at the right. So it's more efficient to technically do it this way. Cool. So now if I run code, I'm going to sacrifice my LeetCode profile here and submit this. I'm going to get a fail, I think. You can see I've done this question many times. I think it's going to fail. I think we're going to get wrong answer, and it's going to be a time limit issue. So let's see. It's taking its sweet time. Yeah, thank you. Oh, it actually worked. Wow. So 99% of the time you run this, it will actually fail because of the n squared solution. Some LeetCode server decided to bless me today and give me a pass. Thank you, whatever server that is. But this is not a great solution. This is not great. So does anyone know how we could actually make this a little bit better? And yeah, LeetCode does have RNG. Depending on what server you get, your solution might fail or pass. Yeah, 95. Yeah, that's almost 10 seconds. That's pretty brutal. Yeah, this one, I'm glad we're recording this because no one would believe me if I told them this.
Yeah, remember you got to look into buts, right? So bottlenecks, unnecessary and duplicated works.
Mm-hmm. So I've seen Dennis throw a word around a few times, which is pretty good actually. I don't know why you're telling me to ignore you, Dennis. That is actually a great idea. So how could we use a hash? So tell me about that. And for everyone, hash map, hash tree, hash whatever, dictionary, those are all the same thing. Hash here, yeah, that's a good one. Those all mean the same thing. So how could we use that here? Can someone tell me? And if no one does, I can just go ahead and do it myself. But I'll give 5 seconds for someone to go.
We access the array n squared times. We're looking at the same thing in squared times, or you can just look at it once and then, yeah. So
okay,
speed up
so
access.
how could we look at it once?
Hash map or set or table, depending on how you want to implement it.
Okay, yeah, but what should I do with that? So like you're giving me that. Great. What do I do with that?
You'd
You know?
want to put the array into a hash map. So that way, if you want to find the value, then instead of looking through the entire array,
Okay.
then you just use the hash map.
So you said put the array in the hash map. What do you exactly mean by that?
Sorry, put each element or put each value into a hash map and use that hash map for iteration instead of the array.
So what's my key and what's my value? That's what I'm trying to ask you here.
So your key would be the index, and then your value would be the value. So for example, we had an example.
So isn't that just an array then?
No.
So let me ask you, what are we trying to find here? So we're given a value, right? And we want to find another value that adds up to our target. So first of all, mathematically, how could we do that?
You could take the target. Actually, sorry, unless if somebody else wants to go, because I'm talking a lot and I feel bad.
Would your key just be your target minus the value?
So that's close. It would actually just be, so the keys would actually just be whatever is in nums, and the value would be the index. So you were very close. So yeah, so let's just go ahead and do that quick. Yeah. So the key would be the contents of the nums. So let me go back to the description here. So our keys would be 2, 7, 11, and 15, right? And our values would be indexes 0, 1, 2, and 5. So let me code it out and then we can talk about this. Okay. So for num in, oops, I actually need the index again. Oops. Okay, cool. So now we're going to go over everything and we're going to say, so again, we were talking about how variable names are very important. I like to call all of my dictionaries /map/ whatever cache. So I'm going to say cache equals this. And this is just like a fancy word that always works and it never seems wrong. So I just always use this. So what I'm going to do is say cache at index nums at I equals I, right? So what this is now doing is saying, if we look at the example on the left, the first one is going to be 2, key 2, value 0. And then the next one's going to be key 7, value 1. Next one's going to be key 11, value 2. And then so on and so forth. So actually, just for simplicity's sake, why don't I print our cache so we can visualize it a little bit better. And I'm actually just going to kill this solution right now. This is going to fail, but it should print before it fails. So let's see. Right. So our key is 2, value 0. Key 7, value 11, key 11, value 2, key 15, value 3. Great. So that's doing exactly what we wanted it to do. Cool. So now, Dennis, since you brought this up, what can we do with this? Or anyone else who wants to talk? I don't want to pick on Dennis too much.
Right.
I think I don't know if you're talking, Dennis. I see like the yellow border around your name, but you are muted. So I don't know.
Oh, no, I wasn't talking. I was just letting somebody else go.
Okay. Does anyone else want to go? Could you subtract from target? That sounds really good. So where would I subtract from target? What would I do with that? Do you want to unmute, Sion? Or you can type through the chat if you prefer as well. Okay, that's fine. So I think I'm just going to go through and actually just show. So Sion is on the right path here. So what we're going to do is I'm just going to go over it and do exactly what he's saying. So essentially, what we're seeing here is now instead of looking at every value and then looking at every other value for it, we can just look at every value. So let me see. He says, go through the array and see if the surrounding value is in the dictionary. Cool. That is exactly the solution. So what we're going to do is say, again, for I in range length of nums. And again, there is a better way to do these loops, and I can show that later if we have some time. But just to keep it simple, I'm going with the range loops. And what we're going to say here is if nums at I minus the target is in cache, right? That means we have our answer. Actually, sorry, Dennis is right. I actually made a mistake here. It is target minus nums at I. Sorry about that. It's live coding and never goes well. So we say, so let's say, for example, our target is 9, right? And we're on the 2. Or we've created our thing. So our target is 9, we've created the 2. So we say, what's 9 minus 2? It's 7. And then we say, do we have a 7, right? If we have a 7, then we're golden. So what do? If we have this, then we say return I and what? Does someone want to tell me what we return? Okay, that's fine. So I will I forgot my return. So we're gonna return I, and then we're gonna return sorry, this is even taking me a second now. Cache at nums at I, right? And this is getting really messy now. So why don't we do something here? So we say value equals nums at I, just to keep us a little cleaner here. So target minus value, and then in here you can say value. There, that's a little easier to read now. So are we done here? Does this work? Can someone want to answer that? Missed a bracket. Thank you. Thank you, Dennis. What's the cache for? Great question, Jared. So essentially what the cache is holding is it's holding pairs, as you can see down here, where the key is a value from nums, and the value of that is actually the index of the array. Yeah, it's a dictionary. So I would call it dict, but that's a keyword in Python, so it always fails when you do that. I can actually rename. Oops. What is happening? Here, let's rename it to dictionary for readability. Great, good refactor. Yeah, it's in the location of the array. So yeah, great. So now, will this code work? Does someone want to answer that? Does the problem assume there's only one pair of numbers like that? So it says you may assume that each input would have exactly one solution, which means only two numbers would ever be the exact solution. And again, you may not use the same element twice. Are we handling this case right now? No. Okay, so how can we handle that case, Dennis? Okay, that's fine. So we can handle the case really in here and just saying if, or yeah. So it would actually be, yeah, it would be in the second loop actually. So we would say if I does not equal dictionary at value here. So if I does not equal dictionary at value, then return both of them. And yeah, so basically if I and j are the same thing, which means if we have the same index, then there's a problem and we won't do that.
Okay, all right.
Yeah, perfect. Yeah.
I don't know if this is wrong, but the first for loop where you have dictionary nums I equals I, aren't you just setting it equal to the counter, the iterator? So it's just going to be 1, 2, 3, 4, 5.
Well, yeah, but I is also the index of nums.
Right, but wouldn't
So
it
as you can see down here, the loop, so it's creating index 2 and sorry 2 and then index 0. Okay, Chris wants to go next. We'll see, Chris. I'll let you know.
Okay.
So yeah, sorry, Dennis, to answer your question, it's setting the value of the dictionary as the key, and then the key of the dictionary as whatever we are in the array, and then I is actually all of the indices of nums.
So the value is going to be the indices.
Yeah, the index, correct.
Oh, okay, so we're kind of flipping it around.
Mm-hmm. So let's give this a run and see what happens. Dictionary value equals I always. So what do you mean by that? If we check if the element is bigger than the target, then we skip searching. Oh, we're actually not returning here, so something is wrong. Target minus value. Oh, yeah. So let's see. Does someone want to debug and see what's wrong here? So someone's saying, I don't know why, but what if we use append function for the dictionary? So how would we use the append function? Aha. So that is correct, actually. So it should be dictionary. See, target minus there. There we go. That was the issue. Thank you, Prabjot. I hope I'm saying your name right, but thank you for that. That's a great call. So now you can see we're working. And if we actually give it a quick, so there's a little button here to run all the example test cases just to make sure, like, quick sanity check before you submit. Great. So let's submit this and see how much faster our time is from our almost 10 seconds. Wow, look at that, 56 milliseconds. So much better solution. We're at 91% of the top solutions now. That is a much better solution. Does someone want to do a time complexity analysis of this? O of n. So why is it O of n?
I mean, it's
So
not,
Humza says it's 1 as well. Why do you say it's 1 actually? Let's start with that. Give him a sec to type. Not exact. We just want big O. Yeah, correct. So so Dennis, you said O of n. Why did you say O of n?
you've got the first for loop, right? And that's
Yeah.
gonna run n times because your array is gonna
Correct.
have n indices. Then you've got your second
Yep.
for loop, and that's gonna run, you assume worst case scenario, so you assume that the your solution is in the last 2 indices. So it's
Mhm.
gonna run essentially through the whole array. And then value equals nums is gonna be O of 1 because no matter how big your input is, that's gonna take the same amount of time. Target minus value, same thing. Both of the if statements are gonna take the same amount of time, O of 1. And so it'll be O of 2n, and then you throw away the constant. So
Perfect. So that was actually an amazing analysis. So this will actually be linear time. And I'm seeing Omar in the chat is asking, I don't get why you need a dictionary to store the indices. That is a great question. So Omar, if you look at our first for loop, we're creating the dictionary. That's fine. So let's look at the second for loop now here, right? Here we're saying if target minus value in dictionary. This here takes constant time. So what this means is to see if this is true, we only need one iteration, like one CPU cycle, I guess is the way to explain it, to figure out if this is true. Whereas if you look at our old code, this line here, this whole part where we're checking in the dictionary, is actually another for loop, which takes n time. So in our new and improved solution, we are actually taking a constant amount of time, no matter how big our input is, to see if our values in the dictionary. However, in the old solution, we were actually had to look at every single possible value in our list n to see if there was a similar number. So I hope that answers your question. If you want to ask a follow-up, you can send a message in the chat and I can answer any more questions you have. So how the if the variable in dictionary implemented in this language. So how the if variable, oh yeah. So basically what this is saying here, this is basically the equivalent of, I'm just gonna write some comments here. The Java equivalent. So let's say we had our dictionary. So we would do dict.get target minus value, and then you assign this to a variable. So I guess I'm just gonna go shorthand Java here and just say like a equals this. Bad variable name. I'm just trying to show an example here. Basically what you're doing is saying if a does not equal null. Oops. Then do something. And then what we're doing is actually using those values. So yeah, all these curly brackets are just the same thing as a hash map in Java. Cool. Yeah, if there's any more questions, we can do that. Or I have another question we can do. And I think Lem has another question he can do as well. So it's up to you.
I'm just
People in the chat.
that's the like this.
Oh, yeah.
If the variable is in the dictionary, is just a shortcut in the, like the compiler would just do a for loop.
No. So the thing is the dictionary has constant time access. So if you're looking at everything in an array, I agree with you. You have to look at every single one of the values to find something, right? But the whole point of the dictionary is it's a black box. Yeah.
I can't believe it has a constant time complexity here, because if there is 10 values, like if it takes 1 second to look for 10 values in the dictionary, it will find it in like 10 seconds. For 1 million value in the dictionary in 10 seconds. It can't. It have to look at one by one. I mean the syntax if variable in something inside the language compiler, it's a for loop. It looks each value.
So the thing is the dictionary data structure is actually not linear the way an array is. So the way dictionaries work is that it is constant time to see if something is in the dictionary. That's just in the nature of a dictionary or a hash map. If you look at the in 2011, you'll learn a lot. I don't know if you've taken 2011 or not, but you will learn more about this in 2011. Essentially, it uses some magical hashing. And essentially, for the purposes of this question, you can assume that a dictionary is a black box. where you give it a key and it spits out the value in constant time. But that is how they work. They are actually constant time. It is not actually searching a list of things. It is just constant time operation.
Thanks.
So, do we have any more questions? And if not, Lam, do you want to take the next question, or should I go to my next one?
You can take the next one. I'm trying to sort out some things right now.
Oh yeah, no worries. The next problem in Java, sure. Yeah, let's do the next one in Java. So the next one I have here is okay. Sorry, I keep getting messages from Chris that he wants to go and do one of them, and he's from the medium room. Chris, which question do you want to do?
Give me your hardest one.
Well, I just have valid parens here, but you have to do it in Java.
Valid parentheses.
You have to do it in Java.
I wait. I have to do it in Java.
You have to do it in Java.
I do it in Python.
No, you can't do it in Python. You have to do it in Java.
Do I? I don't think I remember my Java syntax.
We'll help you. We'll help you.
Yeah,
on the
we'll help
syntax.
you through it. We'll help you through it.
Don't worry about the
like that.
syntax.
I think
No.
Ashir can do.
I can't do Java. Let me do Python. I'm a one-trick pony.
No. It's Java here because some people want to learn Java. They're in first year. They don't know the Python, so they can't really understand the Python
Okay.
too well.
Okay.
So let's
Wait.
go
Am I
with
sharing
Java
my
for this
screen?
one. Yeah, if you want to do
Okay.
it, the
Okay.
question
Give me a
still.
second. Let me just open up my LeetCodes. Is it valid parentheses?
No.
Valid parentheses. Sorry, you can see my screen, right? Can you see my screen?
Yeah, we can see your screen.
Okay, cool. Woo, oh, Nelly. All right, Java. All right. Okay, so how do you do a multi-line comment again in Java? Okay. So let's see here. Given a string S containing just the characters open brace, close brace, open brace, close brace, blah, 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 determine if the input string is valid. An input string is valid if open brackets must be closed by the same type of bracket. Okay, that's good.
Chris, do you mind zooming in because people can't
Oh,
really.
whoopsies. What was it? Command. How's this?
Perfect. Thanks.
Is that better? Okay, great. So basically we have a string of 3 different types of open and close brackets, and we just want to know if it's valid. Okay, that's good. So an input string is valid if an open bracket is closed by the same type of bracket and open bracket is closed in the correct order. Okay, so this one here is definitely the most important, I guess one to like follow, of course, right? Because if we had this open bracket and then we had this open bracket and then it was followed by this, like this is going to be a problem. But you know what would actually make this problem a lot more simpler is if we could reduce our input to only kind of like invalid characters. That makes sense. So if I had, you know, something like this, and then I would say like this and this becomes much more easier to resolve if I could get rid of this, which I know is valid, and then I'm left with this. And I guess the problem is like, how do we know when something is valid? Well, I would think to use a stack where you can like push and pop characters. So if, for example, as I'm processing my string, like character for character, if I saw an open bracket like this,
Chris,
I know.
Sorry, Chris, someone in the chat is saying they're a little lost. So can you just circle back a little bit? Yeah, just keep the chat open on this.
Okay, so what made you think to use a stack? Okay, so what I'm trying to say is if you can reduce your input to only invalid characters, it really helps you to solve the problem, right? So if this is my input, let me simulate how I would use a stack. So the first character I see is this open bracket. Now the next one that I have to see is either another open bracket. Like if I saw something like this, it's totally fine. If I saw something like this, it's totally fine. But if I saw a closing bracket, I know it has to match what is currently at the top of my stack, which is this bracket here. So if I were to see this, that's obviously not great. If I saw this, it's obviously not great. But if I saw this character, for example, now this is a match, right? And the great thing about stacks is you can push characters onto the very top of the stack, and you can pop things from the top of the stack. So if I know that I have a valid match, I can just pop this, and I can pop this, And I know that the next character that I have to see is either another open bracket or another closing bracket. So was that explanation like better? Whoever said that they didn't understand, is it okay now? Wait, Grace first. Where are you lost? Sorry, Grace, did that explain that better too? Okay, so Grace, I'm going to take your silence as you understanding what I meant. So I'm just going to keep on going. So yeah, like I said, it would be great if I went through this like character for character and removed things that were valid. So I'm just going to go through like a dry run example of this problem. So I see an open bracket, I see a closed bracket. This matches what's currently at the top of my stack. So I delete and I delete. The next character I see is this. And then the next character I see is this. And I know this is a valid match. So I delete and I delete. And then I see this open bracket. And then I see this closing symbol. And this is a valid match. So I will delete and I will delete this. And this is the end of my string. And I know that like this is valid. But now let me actually change this and make it something like this instead.
Sorry,
So-
Chris.
yeah.
Quick question. As much as I love interrupting you.
Yeah, Dennis, go ahead.
Would you add, so you would see an open bracket, closed bracket, like the proper one. So you would add it onto your stack, and then I guess you would check that they're valid, and then you would remove them? Or are you removing it from the input? Like the input
Sorry,
string?
from the input?
Like, are you physically, like, are you removing them from the input string, or would you add them to the stack, check to see if they're valid, and then remove them from the stack? Pop them from the stack.
Yeah, I'm not modifying my input string. I'm modifying like my stack.
Okay.
So
you'd-
it would probably help if I did this instead. So this is like, let's just
Do you want to show what your stack looks like?
yeah, this is my stack, right? So I'm gonna take this example here on line 9. So the character I see is this. So this is now at the top of my stack. Now the next character I see is this one. So on my stack now becomes this. And I say, okay, wait, this closing bracket literally matches this. So that means we can pop from our stack and we could pop from our stack. Right now we're at an empty stack. Now the next character we see is this open bracket. So we're gonna add it like this. And then the next character I see is a closing bracket. So I'm gonna put that into my stack like this. And I say, okay, wait, this character I just added matches the previous one. So I can delete this as in pop it from my stack and this pop it from my stack. And then the next character I will see is this one. The one after that is this. Now here's where the problem is. Since this is a closing bracket, why don't I just check the character behind this and say, the character behind this one has to be this. Otherwise, it's invalid, right? As soon as I see this mismatch, I could return false because I know that this is not a valid parentheses. So I hope this makes more sense. If there's any like misconfusion, or if I talk too fast, like please let me know. But I'm just gonna get into my implementation now. So how do you make a stack in Java? So is it list? And then I think it would be like string. I guess I could use like characters. Characters is equal to help Chris make stack. Oh my god, can I just do this in pseudocode? Like I really don't know Java's. Ari, help me out. Can I type it in Python? You can do the translation in Java.
I think there's a stack class, so you can probably try and look
But
up
we
the
wanna run it.
documentation for that
Okay.
like,
Okay.
API.
So I'm gonna write pseudocode and then I'll translate it because the way that I like to solve problems is like just first like write like fake code. So so like I have like a function here. I'm gonna take in string, and what I'm gonna do is say, okay, so stack is equal to like my stack. So I have a stack here. So for character in my string. So for each character in my string, what I'm gonna do is say, okay, if it's an open bracket, so if character is an open bracket, add it to my stack, right? Because if I just had a bunch of these, so if I had a bunch of like this, and then this, and then this, and then this, I can't really check to see if like this is a valid mismatch or not. So I'm just keep adding characters onto my stack. So that's gonna look like this, it'll look like this. This one will become this one, and this one will become this. Like I don't start popping things from my stack until I see a closing bracket, right? I hope that makes sense. So if the character is an open bracket, which means it's one of the 3 types of openings, we'll just add it to the stack. Otherwise, so else, this is a closing bracket, and I need to check if the top of my stack is matching like whatever character I see. So if the next character I saw was something like this, now my stack would look like this, right? So if I ever see a closing bracket, the character behind it, as in this one, has to be the like correct match. And if it's not, then I can just return false. Otherwise, this is a closing bracket, and I'm going to check if the top of my stack is matching. Now, this is where we're going to get to like another layer of if statement. So if the characters match, we'll pop from the stack. But if it doesn't match, so at the first sign of a mismatch, else we'll return false. This is not a valid parentheses. Okay, and then if you can get all the way through processing your character, what would you think to do? Would you think to return true? Okay, well that's not true, right? Because in this string here, if you just had this, that means at the very end your stack looks like this. Now we never returned false because we never saw a closing bracket. But it's not valid if you only have open characters. So what you have to do is return if the stack is empty or not. Because if the stack has characters in it, it means you had open brackets that you never resolved. And if your stack is empty, you resolved every open bracket that you ran into. So I hope that makes sense. Now I need help translating this to Java. So I don't know if people want to see me struggle like how to make a stack.
I think you want to first import the array deck class. I think that's the best one you could probably use.
Everything's usually pre-imported.
LeetCode is already imported for you, so
Okay, then you don't need to import it.
I use a stack class in Java. Push. How do you make one? There you go. Stack class. Okay, awesome. So I'm gonna have my stack here. Stack is equal to new stack. Now, or is it character? Oh wait, it's string character. I remember this. String character. Oh, wait, this should not be. This should be string. There we go. String character in S. Is this valid Java syntax? Can you do this?
I think so.
Yeah.
You're
That's fine.
iterating over this. Yeah.
Character. Okay, let's see. This is how I'm going to verify if, yeah, see, okay. You can't use a for each. Oh, this is why Python is so good. How do you do this now?
Oh, so go back.
Oh, sorry.
Undo what you did. Yeah. Change string to character.
String. Okay.
Yeah, and then oops. And then do s dot to char array.
S dot to char array. Let's see. Missing return statement, which is great, which means we got spent. So return false. So we'll just do that for now. Cannot find some. Oh my god, it's lowercase, isn't it? Okay, great. So this I'm gonna just make sure I have great things. So I could really just do like return stack dot is empty. Okay. So for each character in my input string, what I'm gonna do is say if character is equal to a open bracket, or character is equal to the other open bracket that we can have, or character is equal to this one that we have, then what do we want to do? Well, like we said in our pseudocode here, we're just going to put it into our stack, the stack dot. Oh my god, I'm so used to Python. Thank you.
Yeah, just remember to have the ors as
there you go. Okay. Stack dot push character. This is great. Now, what did we say otherwise? Okay, so what if it wasn't an open character? Now it's a closing character. So if we get into here, we know that this is a closing character. So if character is equal to this, then what are we checking? If this is the character, or sorry, if this is what, oh my god, it's this one. If this is the closing character that we're currently looking at, then that means at the very top of our stack, it has to be what? It has to be this, okay? So if, how can you check the top of the stack? If
Stack.pop.
to peak, because I just want to see what's at the top. Wait, whoa, we're not popping just yet. If it's this, then we're good to go and we can continue. But if it's not this, then we want to return false, right? Return false. Lowercase again. Okay, but that was just for this case, which means this is going to be a really ugly nested like if statement. So else if what character is equal to, I think it's this one, then if stack, okay, you know what? This isn't equal to this, to return false, and then else, which is the last possible one. We're going to be checking if this. We're going to check if the very top of our stack is equal to this. So what the approach I'm trying to go for is a early return, which is at the first sign of a mismatch, just return false. Otherwise, like keep on going. So if you could get through all of these and you did not return false, then that means it has to be a valid match. So if you get all the way here, we're going to do stack.top. Okay. And then that should be it. At the very end, you want to make sure that your stack is empty, like we said. So I'm going to run it. Character cannot be converted to a string. Stack.put. Okay, this should be character. Great. Okay, great. True. Run all the example set test cases, which is true, and submit. And it's false because. Okay, this is a really great error that I ran into, because I was kind of preemptive in writing my code. So the input is a single character where the only character is this. Now, why did I run into an error? Because I said, if the character is this, then push it. But otherwise, if the character is equal to this, we're going to say if stack.peak is equal to this. But that's a problem, right? Because there's nothing even in our stack to check. So what we should do is if it's a closing bracket, we should at least make sure we have at least one character in our stack. So if stack dot is empty is, how did I do it? Yeah. If our stack is empty and we ran into a closing bracket, we have to return false, because how could you have a closing bracket without an open one? So return false. And I hope that one will work. Otherwise, that would be embarrassing. Let's run that individual test case and it's good to go. Submit the whole thing and we're good to go. Awesome. Whew. That was nerve-wracking. I hate Java. Okay, great.
Chris, quick question.
Yes, Dennis.
Could you like make the code a little nicer or speed it up a bit, because you're peaking 3 times? Could you pop it once? Because when you pop it, it returns the value. So you could save that value to a variable and then I guess just compare the variable. Sorry, I just realized that's the same amount of work.
You could do like stack.pop at like the very top here if you want. Like, I don't think there's a difference in like time complexity, if that's what you mean, like speed it up no matter what's the same time complexity. There actually is a way to make it like cleaner. Cleaner is different from like faster, because no matter what, there's like, you're not going to find a more optimal solution. If you used a dictionary, it would make this like much more easier. Like even like a hash set. Like how do I use a hash set? Like hash. Oh wait, okay. Is set. You can do this, right? Whatever. You know what? I'm not even going to bother worrying about it. This works. With any questions? Slap a hash map on the problem. So Ari, how did I do?
I was looking at something else for some of it, but you did pretty good. I think you did okay.
Okay.
C+. I'm joking. It's like a good B+.
You get A+ because you wrote out the steps in English first as comments, and then you filled in the code after.
Yeah, that's true.
See,
you beat me there.
See, you know what? You want to know what this looks like in here? So you see how many lines this is? It was like what, 30 lines? This is my Python solution, which is 16 lines. It's so easy. Please, everybody use Python. Okay, but yeah, this was a pretty good problem. This is actually one of my favorite problems as well. You can see by the number of times I even tried using it. And you know what's funny is even though I have solved it numerous times in the past, I have gotten it wrong again later on. because you really have to think about every edge case that you could possibly get. And I know what every one of these failures is that I always forget to check something like this. So yeah, this is always a good problem to revisit from time to time. But yeah, thank you for having me, Ari.
Chris, can I ask a question?
Yes, absolutely.
So like in interviews, right? And you forget edge cases like this,
Mhm.
how does that kind of result? Like, does the interview tell you like, oh, what about this? Or is it like, oh, you screwed up, goodbye, like?
So
Yep.
it really depends on at what point in time do they bring it up. So like, let's say I have 30 minutes for an interview and within like the first 10 minutes, I can crank out this solution. Then they'll probably be like, okay, that's great, but what about this scenario? And then you'd have time to like fix it. But if it took me like 25 minutes to crank this out, and then at the very end, they say like, okay, this is great, but you forgot this like corner case, it probably like sunk you, which is why in the very beginning, if I remembered this corner case at the very beginning, I would have been able to incorporate it in my solution from like the very beginning, if that makes sense. Right? So
Right, that makes sense, yeah.
that's why at the beginning of every problem, I actually always try to write it out in English, because usually at this point in time, I would have stopped myself and been like, okay, wait, you can't pop from a stack if like it's empty, so on and so forth.
Do you go through the edge cases during like in the beginning in the English phase, or do you go through like in the end where you're like, oh, I made a mistake?
I usually try to catch all corner cases before I even begin programming, because I've run into a situation where I write out like 30, 40, 50 lines of code. And then I will remember, oh, wait, there was a corner case I missed. And that means refactoring all 50 lines. So if you can catch it sooner than later, it would make your life a lot easier in an interview. And that's honestly something that sunk me like numerous times, where at the end of writing like a really large chunk of code, the interviewer said, okay, but what about this, scenario? And I had to delete all 50 lines. I had to retype it up. So yeah, definitely if you can catch it sooner than later, it's way better. In the chat, I see.
Yeah.
Abdullah asked, in terms of jobs, what do companies prefer, Java or Python? It doesn't really matter what language you use. I would say like the top 3 most popular languages is C, Java, and Python. So it really doesn't matter. And yeah, and sunk means yes, I failed the interview. Yeah.
I'll just have you guys know that IBM actually asked my friend this question for his technical interview. So this is one of the good questions to look at as well.
Yeah, that was fun. That was pretty fun. So if there are no more questions, I'm just gonna like give.
Chris.
Oh yes, Dennis.
Sorry, but this isn't about this. It's so you're talking about edge cases, right?
Yeah.
But I don't know. For me, I feel like when I'm trying to come up with a solution, and then I come up with an idea, and then I think of an edge case that kind of sinks my solution, then it feels like I'm kind of back to square one. So do you think a good way of doing it is you just try to come up with a solution for the general cases, and then you write that out in whatever pseudocode or English, and then you start looking through your pseudocode, and then you try to spot all the edge cases and incorporate that into your English or your pseudocode, and then once you're done and you think you caught all the edge cases, then you write it in real code.
Yeah, honestly, people have their own different way of approaching problems. Like some people would prefer to let me just type out code and then I'll think about it. For me, like the sooner you figure it out, like the better. I'm putting my Java solution on the left and I'm putting my Python solution on the right just to show, hey, one of them is really shorter than the next. But there was a really great question that I'm going to answer, which is, does that mean we should focus on mastering one language for beginners? Like, yes, like absolutely yes. I don't think there's a point in knowing how to solve one problem in 5 different languages. Like there's really no point. If you can get really good at one language and like understand its entire ecosystem, like how do you use a heap in this language, a queue, a stack, like an array, all the string manipulation, like functions, there's no point in doing all that work again in like a different language. So yeah, I'm just gonna end my little spiel by saying that. I'm gonna stop sharing my screen.
Well, looks like we're at 8 p.m. So yeah, I guess some of the final notes is that,
Yeah, they're taking their time. Like they're having a great time, I think, in the meeting in our room. How was it? How was it there, Chris? Like, what was people's response?
Sorry, how was the sorry?
How was the medium and hard room? Like,
Oh, so we conducted like mock interviews as well with like medium problems. I don't think there was anyone that actually was able to solve any of the questions, to be honest. But we had a really fun time like just explaining how to solve the problem. And we actually talked about a lot of like things that people never knew before, like heaps, like how can you use this data structure to like solve this problem? Like a lot of people like learned about like new data structures. That was like fun and stuff.
yeah, I think they need a little bit more time. So like, we're just gonna keep the breakout rooms open for now, I guess. But yeah, I think we're done for today's easy session.
Fayez, we got a question in the chat here. A Discord server for more events like this. You want to plug both in there?
Yeah, you can
CSHub
link
and
to LES if you guys want to host anything, but like for coding stuff, we have a lot of events planned in the future.
we'll put both in there because
Yeah,
we'll put both. So go ahead. I don't know if I have CSHub, so you can go ahead and do that.
yeah, I'll put the CSHub's Discord. We are basically Lasson's biggest computer club. And
I did it already.
oh, you did?
Yeah.
Perfect. There we go. You can join both our Discords. Yeah, and please look at the announcements chat. We will ping everyone too. And just to be, just to get more members. And this is all obviously for your own good. We're gonna host like other coding sessions like this. Maybe even like do practice coding problem solving like on Discord soon. We also do resume reviews on our Discord. People are pretty active now. It was dead for a while, but now I see a lot of people post their resumes, and then we have people commenting on what needs to be added or what needs to be removed, stuff like that. So yeah, if you guys are interested in that, you can obviously join our Discord. And yeah, also join LES's Discord too, because they also have events planned, I assume.
Yeah, we have a variety of events that we plan every year.
Yes, they're planning the YEC. I think it's they have a programming competition too.
Programming is finished this year, but we host it every year. So
yeah, there's also on Hack coming soon. I think registration's still open.
That's not us, but yeah, on Hacks.
I think Dennis got a question up there.